Okay, we're going to talk about the tangent ratio today, and this is really the introduction to the trigonometric ratios, which we call the trig ratios. A trig ratio is a ratio of lengths of two sides of a right triangle, so in order to use the trig ratios, you have to have a right triangle. So the first thing we're going to look at is the tangent ratio, and in order to do that, I'm actually going to describe a phrase that we use to kind of remember this stuff, and it's called SOHCAHTOA. So, SOHCAHTOA. Okay, and so, or S means sine. Okay, and we actually abbreviate the word sine when we're dealing with the trig functions as SIN. Okay, we just drop the E. But what it actually does is it references some sides of a triangle, and there are three sides to a right triangle. One is called the hypotenuse, the other is the opposite, and another is the adjacent. So the two legs are opposite and adjacent. So I'm going to show these here in a minute after I go through the ratios. So sine is equal to the opposite side divided by the hypotenuse. Okay, when you're dealing with CA means cosine is equal to the adjacent side over the hypotenuse. And then the one we're studying today is tangent. The tangent is equal to the opposite side over the adjacent side. Okay, and so we have SOHCAHTOA there. And so to describe that, what I'm going to do is I'm going to deal with angle A. So using angle A, and I'll write that here. Didn't do that. But using angle A as my reference, what I mean by that is I am dealing with this angle, angle A. Notice I traced it. Angle A is my reference. The sine of A would be equal to a ratio of those side lengths. So if I have A as my reference, what I want to do is to figure out which is my opposite and adjacent. I'm going to trace angle A. It's very easy to figure out the hypotenuse. The hypotenuse is always the longest side of the right triangle. Right? But is AC my opposite or is BC my opposite? Well, the way we figure that out is we trace the angle we're dealing with. So in reference to angle A, BC is the opposite of A. Okay, it's the opposite of angle A. Okay. So the side opposite of angle A is BC. Notice when I trace angle A, it's the side you don't trace. Okay, it's directly across from it. It's at the end of angle A, if you think of it that way. So BC, the opposite, over the hypotenuse, AB. That would be the ratio for sine. So the way we'd write that is sine of angle A, and I'll actually rewrite that here. Sorry about that if that messed you up. The sine of angle A is equal to BC over AB. When I'm dealing with cosine, well, when I'm dealing with the cosine of angle A, so once again, I'm dealing with angle A. If this is the opposite of A, that means this side has to be the adjacent side to A. Okay, adjacent to angle A. Adjacent means next to, okay? Next to angle A. The leg next to angle A, or attached to angle A here, is AC. So it's adjacent, AC, over the hypotenuse, AB. And then finally, the one we're studying today is the tangent. So the tangent of angle A, and by the way, these are the word sine, the word cosine, and the word tangent. They are lowercase. So I have this bad tendency and make them uppercase. Okay, tangent of angle T or of angle A, excuse me, is equal to the opposite side, opposite of A, which is BC, over the adjacent to A, which is AC. Okay, those are the ratios. Now that's dealing with angle A. If we were to switch it and deal with angle B, it would be something different. Okay, and we'll see that in the next problem here. We are going to focus on tangent today, though, and tomorrow will be sine and cosine. Okay, so the first thing we need to do, and you'll keep noticing it, I'm focusing on the SOHCAHTOA piece. Since we're dealing with tangent, that's the TOA. And just a quick reminder, tangent, the TOA, tan is equal to opposite over adjacent. The side opposite over the adjacent side. So when I'm finding the tangent of angle Q and the tangent of angle R, and writing it as a fraction and decimal rounded 4 places, well, the tangent of angle Q, that means I'm going to trace angle Q. When I trace angle Q, the side I do not trace is my opposite. That is opposite of Q. And I like to write what it's the opposite of, and you'll see why here in a minute, which means this side, the other leg, is adjacent to angle Q. The longest side, remember, is always our hypotenuse. It doesn't matter which angle we're dealing with. Longest side is always the hypotenuse. So when I'm finding the tangent of Q, the tangent of angle Q is equal to, remember, that's opposite over adjacent, right? TOA, opposite over adjacent. So the tan of angle Q would be the side opposite, which is 21, over the adjacent side, which is 72. So that's the ratio. Write it as a fraction. We should always reduce it if we can. So 3 goes into 21 7 times, and 3 goes into 72 24 times. So we have 7 over 24. Okay, that is the ratio for the tangent of angle Q in simplest fraction form. Now in decimal form, to 4 decimal places divided by 24, that's 0.29 2917. Now, if you have a graphing calculator or scientific calculator, you would type in tangent, or excuse me, not tangent, you type in 7 divided by 24 and just get a decimal. You don't have to use the word tangent in there at all. Okay? The next one, notice we're dealing with angle R. So I'm going to switch up my colors here so we can see this. So the tangent of angle R is equal to, well, it's equal to the opposite of angle R over the adjacent. Now notice when we're dealing with angle R, that's a different angle. So I'm tracing it. The side that is not traced here in this new color is SQ. This is the opposite of angle R, the side opposite of angle R. This side is now the adjacent to angle R. All right, so what's happened, opposite, 72, over adjacent, 21, my fractions just flipped upside down, right? Once again, reduces to 24 and a 7, so it's 24 sevenths. There is my fraction form. And 24 divided by 7 is 3.4286 to 4 decimal places. Obviously rounded off there. And once again, you're just doing 24 divided by 7. No need to use the word tangent in your calculation. Okay, the time we actually use the tangent button on our calculator is when we're finding values of a side length. So let's move and utilize that ratio in a different way. Okay, so remember, TOA means tangent is opposite over adjacent. Okay, so here's the angle I'm given. The way I handle these is I trace the angle I'm given, and I label my sides. Here's my hypotenuse, here's the side opposite of angle 52, and here's the side adjacent to angle 52. Now notice I used this angle because that's the one they gave, and I'm dealing with opposite and adjacent because I'm trying to find the opposite and I'm given the adjacent. All I need is one piece as long as I know everything else, or excuse me, all I need is one side as long as I'm given an angle. So I can use tangent, the tangent of my angle 52 degrees. And remember, when we had the letter R here in the previous problem, this said the tangent of R. Well, if you know the measure, we just replace that with our degree measure. The tangent of our angle is equal to the opposite over the adjacent. You now have this equation, which technically is a proportion, but the way you solve it, you try to solve for x. You got to multiply out that 8. Oops, excuse me there. I'm going to multiply this by 8 and this by 8. The 8's cancel. I'm left with x is equal to 8 times tan 52. Now it's important when you put this into your calculator, tan 52 is a numeric value. Okay, and if you push tan 52 on your calculator, you're going to get one of two things usually. You're either going to get a positive number or a negative number. If you get a negative number when you push the tangent button in 52, that negative number actually means you're in the wrong mode. You need to switch to degree mode. You're measuring in radians. Okay, so right now we're dealing with degrees. How do I know that? Because it says 52 degrees. Radians, we'll deal with that a little later this year, and then in Algebra 2 and Calculus. Okay, so we're dealing in degrees, so make sure your calculator says degrees. If it's a scientific calculator, in one of the corners it'll say DEG. That means degrees. If not, if it doesn't say that, then find a button. On most scientific calculators, it's a DRG button, and push that, and then select degrees. If you're on a, excuse me there. If you're on a graphing calculator, so there's scientific. If you're on a graphing calculator, what you need to do is you need to select mode. There's a button that says mode, and then after you select mode, you want to scroll down until you find the radians or degrees. And you want to make sure that degrees is highlighted. It'll say radians, degrees, and you want to find the option that is degrees. And then in calculators, when you reset the memory, it automatically reverts back to radians. So just make sure that you double check what mode you're in. Otherwise you do all these problems incorrect. You want to be in degree mode. Okay, so doing the math here, 8 times tangent 52 is going to be equal to, rounded to the nearest tenth, 10 point, all right, 10.2. That's rounded to the nearest 10. Okay, well, let's go ahead and try a different one here. I'll switch up some colors here. So in this problem, hopefully you're pausing and trying on your own, but let's trace that angle. So in terms of that angle, the opposite side is 12, the adjacent side is x, and hypotenuse doesn't have anything, but we'll label it anyway. So when I'm dealing with it, I'm dealing with the tangent of a 34-degree angle is equal to the opposite side, 12, over the adjacent side, which is x. Whenever you have your variable in the denominator, make sure you understand how to get that out. So the first step is to multiply both sides of that equation by x. Now by doing that, the x's cancel, and I'm left with tan, or x tan, x times tan 34 equals 12. So if I want to get the x by itself, I now need to divide both sides by tangent of 34. So when I divide out tangent of 34, remember that's a numeric value. It's a number. Or if you type in tan 34, it's going to give you a value. It's a ratio. Okay, that's going to be equal to x, and then 12 divided by tan 34 is equal to 17 point, I believe, 8 there. 17.8. Okay. Well, let's go ahead and take a look at this in another way. Let's say I'm dealing with special right triangles, and I know that the tangent is equal to the ratio opposite over adjacent. Okay? Use a special right triangle to find the tangent of a 60-degree angle. Well, some special right triangles, remember we have a 45, 45, 90, and a 30, 60, 90. So go ahead and draw in a 30, 60, 90 here since we're using special right triangles. Here's my 60, here's my 30. Okay. Remember the relationship in the sides here. The shortest leg is x, the hypotenuse is 2x, and the other leg, the longer leg, is x root 3. So if I'm using special right triangles, or a special right triangle to find the 60-degree angle, what I'd want to do is I'd want to trace that angle, 60-degree angle. In relation to the 60-degree angle there, the opposite side is x root 3, and the adjacent side is x. So the tangent of a 60-degree angle is equal to the opposite, or x root 3, over the adjacent, or x. And notice I have x root 3, x times root 3, and I have divided by x. What happens? Well, the x's cancel. So the tangent of a 60-degree angle is equal to root 3. No calculator needed. Okay. Let's go ahead and try one more problem here. And before we do that, we need to know what an angle of elevation is. So the key word here that I would emphasize like multiple times is the word horizontal. Okay, horizontal. An angle of elevation is an angle, or the angle that an upward line of sight makes with a horizontal line. So in other words, here's my horizontal line. You always need the horizontal line. Always. Okay? Well, the angle of elevation starts at that horizontal and it goes upward. So the angle swept out by maybe you're standing here and looking up. That's an angle of elevation. If you were looking down, by the way, which is in our next lesson, that would be called an angle of depression. But when you're looking, oops, don't need that. When you're looking up from your horizontal line, that's an angle of elevation. Okay, so we have this scenario. You need to cut down a tree in your backyard. To be sure that there's enough room for the tree to fall without hitting a fence, you need to know the height of the tree. When you stand 50 feet from the base of the tree, the measure of the angle of elevation from the ground to the top of the tree is 42 degrees. What is the height of the tree to the nearest foot? Now, I'm going to draw a picture, and it's not going to be anything actually amazing or miraculous, but here we go. We've got this tree. All right. Now this situation isn't going to be as realistic as it normally could be, because I've at least in the textbook that we're using, some of the examples I see, they give you an angle of elevation like we have here of a person, and they're looking up at the tree, and there's your horizontal line. Now, I guess that's probably a better picture right there. And we have our 42 degrees. and we are 50 feet away, and we're wanting the height of the tree. Well, really, in an everyday situation, you would have to take into account the height of the person as well. In this scenario, we're not going to do that, okay? But that would be a situation where you'd have to do that if you're really dealing with this, okay? So right now, we're just going to base our height on, or the height of the tree on these measurements, 42, 50, and then we'll have our x over here. So dealing with this angle, the opposite side is over here, and the adjacent side is right here. So we have the tangent of a 42-degree angle is equal to the opposite side, x, over the adjacent side, 50. So to solve, we'd have 50 times tan 42 is equal to x. Rounding to the nearest foot, 50 tan 42, rounding to the nearest foot, that ends up giving us a height of 45 feet. Okay, so we're saying that x is 45. So the reality is, like, if we were in a true horizontal line, this is the answer to the problem we're dealing with. But if we're dealing in reality here, and obviously the picture is not to scale, that would mean 45 feet stretches from here up to here. That would be 45 feet. We'd also have to add on the height of the person. So if I'm 6 foot tall, or if it's 6 foot from my eye level to the ground, I'd have to add on another 6 feet. Now, like I said, the textbook isn't having us do that, but that's a more realistic scenario where you'd have to add that on, and that would be 45 plus 6, or 51 feet, if you're adding on the height of the person there, which is more realistic. The way we're measuring it, or at least a problem like this that I referenced out of our textbook, the way it was measuring it would be like if you were laying on the ground looking up, okay, where your height doesn't matter. But anyway, I think we get the point there. So hopefully that helps out. I think that's it. Yep. Good lucky.